Hello, and welcome to the Global Discovery Series, sponsored by Penn Alumni Travel and Education. As we wait for more guests to join us, I encourage you to introduce yourself using the Q&A icon on the right side of your screen. Let us know who you are and where you're logging in from. I'm Emily LaRosa. I'm Assistant Director of Penn Alumni Travel and Education, and I will be your host for today's session, The Risks of Climate Change with Professor Michael Weisberg, which is co-sponsored by Climate Week at Penn. While we are all staying safe at home this fall, this series will allow us to explore the world together virtually with Penn professors who will share their new and innovative research with us. I'll take a look and see if anyone's introducing themselves yet. Please go ahead and introduce yourself using the Q&A icon. While I wait for some people to join us, I'll continue. As you continue to introduce yourselves using that Q&A icon, I'll run through a few housekeeping tips as we prepare for today's session together. Hello to Lauren from Long Island, New York. Glad you could join us. First, I encourage you to enter your questions throughout the webinar using that Q&A icon, which you are already doing. Great job. We'll do the majority of our Q&A at the end of the session, but if you're experiencing technological difficulties or have questions about Penn alumni resources, we'll try to answer your questions directly during the presentation. Please know also that you will likely experience a delay during today's presentation as BlueJeans converts our live session into a stream, but we will see and respond to as many questions as we're able, and we look forward to interacting with you. Lastly, I'd like to note that today's speaker, Professor Weisberg, will be our faculty host on a Penn alumni travel trip to the Galapagos in September 2021, so next September. You can view this trip and our entire, if somewhat modified, 2021 schedule on the Penn Alumni Travel website at www.alumni.upenn.edu/travel. Please don't hesitate to reach out with questions. You'll find my contact information at that site. So let me take a look and see who we have today really quickly. It looks like we have Joy in Philadelphia, Susan from Pennsylvania, some more Pennsylvania people. Wonderful. Welcome, everyone. Hello to Krista and Hannah, both in the Philadelphia region. Lyle from Montana. Great to see some people from across the country. Welcome. Las Vegas. Randy, welcome. Let's see. San Francisco, California. Good morning to Harshad. Welcome, Carol from New York. That's great to see that you're all using that Q&A icon. Please continue to do that throughout the presentation today. Okay, so without further ado, it's my pleasure to introduce our featured speaker. Michael Weisberg is Professor and Chair of Philosophy, as well as Senior Faculty Fellow and Director of Postgraduate Programs at Perry Worldhouse. He serves as Editor-in-Chief of Biology and Philosophy, Advisor to the United Nations Framework Convention on Climate Change's Nairobi Work Program, and directs Penn's campus-wide transdisciplinary research in the Galapagos. He is the author of Simulation and Similarity, Using Models to Understand the World in Galapagos, Life in Motion. Much of Professor Weisberg's research is focused on how highly idealized models and simulations can be used to understand complex systems. He also leads efforts to better understand the interface between humans and wildlife, between humans and the climate system, and how scientific issues are understood by communities in the Americas and in East Asia. Professor Weisberg received a BS in chemistry and a BA in philosophy from the University of California, San Diego in 1999, and continued graduate study in philosophy and evolutionary biology at Stanford University, earning a 2003 PhD in philosophy. So Michael, thank you so much for joining us today. I now turn the platform over to you.
Thanks so much, Emily, and thank you everybody for joining us today. It's not the same as traveling, but we're going to try to make the best of the time that we have together. I've included in my presentation pictures that I've taken on wonderful alumni trips to hopefully keep you all engaged and to be thinking about all the wonderful places we can go to together in the future. So I'm going to just share my screen. One moment, please. Today I am going to talk about climate change, but we're going to talk about a different aspect of climate change than is the most typical. So most presentations, especially academic presentations given within the academy or to the public, really focus on the physical science of climate change, or perhaps trying to convince a skeptical public about the reality of climate change. Today, I want to actually just assume all of that as background, despite saying a small amount about that at the beginning, and actually really focus on the risks of climate change, and to talk about the work that is happening in the IPCC, the Intergovernmental Panel on Climate Change, the UNFCCC, the United Nations Framework Convention on Climate Change, or UN Climate Change, and the work happening right here at the University of Pennsylvania on these topics. So, all right, let's dive into it. These penguins are concerned about climate change. So, all I'm going to say about the physical science of climate change is this. Climate change is basically the result of the sun is shining on the Earth. The incoming radiation from the sun is normally partly absorbed by the Earth, partly absorbed by the atmosphere, and partly reflected back into space. As the amount of greenhouse gas increases in our atmosphere, more of the energy of the sun is increased in the atmosphere, and that leads to the Earth warming up, the global mean temperature increasing. Everything that we're going to talk about today is essentially the result of this very basic phenomenon, this warming. The warming that's happened approximately 1 degree centigrade since the beginning of the Industrial Revolution. So some of you might remember 5 years ago, this was projected onto the Eiffel Tower, no plan B. And they projected no plan B onto the Eiffel Tower in reference to the negotiations about the Paris Agreement, which was agreed upon in 5 years ago. So I want to tell you to start with a little bit about the Paris Agreement and then the framework convention that it sits inside. So the UN climate scheme, so the international negotiations about climate, are conducted inside something called the UNFCCC, the United Nations Framework Convention on Climate Change. That term, UNFCCC, gets used both to refer to the actual document, the treaty that's called the Framework Convention, and also the secretariat or the professional staff and all of the parties to that document, and the parties being the countries that signed it. Now, what I want to talk about today is not the more famous part of the Framework Convention and the Paris Agreement, and that's the actual goals of reducing greenhouse gases. That I'm just going to assume is background in this talk, although happy to answer questions about it. But I actually want to talk about what the agreements, the Framework Convention and what the Paris Agreement say about the risks of climate change. This is a subject that's called in the climate community adaptation. Typically, climate's thought to have basically three major parts, the study of climate. There's the physical science of climate change. There's the mitigation of climate change. That's reducing greenhouse gases in order to lower the global mean temperature, or lower where the global mean temperature is going towards. And then there's adaptation to climate change. And adaptation is about how we respond to the climate change that's already with us and the climate change that we expect to happen in the future. So Article 2 of the Framework Convention on Climate Change, I will read the whole thing and just focus on the part in bold. It says that the ultimate objective of this convention and any related legal instruments that the Conference of the Parties may adopt is to achieve, in accordance with the relevant provisions of the convention, stabilization of greenhouse gas concentrations in the atmosphere at a level that would prevent dangerous and anthropogenic interference with the climate system. Such a level should be achieved within a time frame sufficient, and then this part in bold is very important for today, to allow ecosystems to adapt naturally to climate change, to ensure that food production is not threatened, and to enable economic development to proceed in a sustainable manner. So this was adopted in 1992, and this is a time when I think climate was not nearly seen as the existential threat that we think of it today, but already when the framers of this convention wrote the article that gives the objective, they talked about it in terms of allowing ecosystems to adapt naturally to the climate change that was already coming, and then basically to protect people, to, on the one hand, ensure that food production is not threatened, and on the other hand, to enable economic development to proceed in a sustainable manner. And what that means is, the goal of the convention is to simultaneously protect the world against climate change, but also not say to the developing world, you have to stop developing. You can't build new energy systems. So this was written in 1992. In 1995, the Paris Agreement, which was negotiated inside this framework, but is of course a much more refined version of it, continues some of the same themes that I just want to flag for you. I'll read you the whole thing, but again, especially notice the parts that are in bold. This agreement, in enhancing the implementation of the convention, including its objective, aims to strengthen the global response to the threat of climate change in the context of sustainable development and efforts to eradicate poverty, including by, and then these are what are sometimes called the three goals of the Paris Agreement. A, holding the increase in global average temperature to well below 2 degrees centigrade above pre-industrial levels, and pursuing efforts to limit the temperature increase to 1.5 degrees C above pre-industrial levels, recognizing that this would significantly reduce the risks and impact of climate change. B, or second pillar, increasing the ability to adapt to the adverse impacts of climate change and foster climate resilience and low greenhouse gas emissions development in a manner that does not threaten food production. And then C, making finance flows consistent with a pathway towards low greenhouse gas emissions and climate resilient development. So these three pillars are: one, there's a mitigation target, which is given in terms of temperature. Try to keep the global mean temperature well below 2 degrees and try to get to 1.5. If you follow climate at all, you'll know that 1.5 is a very important goal that's discussed widely. The second idea is that we need to prepare the world to adapt to the adverse effects of climate change, basically not let our food system collapse. And finally, this part about finance flows is really interesting. It's not something I work on, but notice that it says, you know, the world's going to still have finance, but we want to make sure that the financial flow through the world is consistent with low greenhouse gas emissions. So basically a kind of, we're thinking in terms of recovery, but this is just, even when the world is thriving, we want we want economics to be consistent with climate change. Okay, so that's the political side. The scientific side is called the IPCC, the Intergovernmental Panel on Climate Change. This is an organization run by the World Meteorological Organization and the United Nations Environment Program. And the IPCC, which writes the authoritative reports on climate change. And it's organized like this diagram shows. But if you notice, the first working group is about the physical science. The third working group is about mitigation. But I want to focus on this second working group, the one that focuses on impacts, adaptation, and vulnerability, in part because I think it's less well known, but also because this is what I actually work on. I work with Working Group 2, and also a lot of the interesting efforts at Penn really could be seen as Working Group 2 kind of efforts. This is not just my work, but for example, the work done in the Design School at the McHarg Center. So the IPCC in the last year and a half put out, actually I guess the last 2 years, put out these three special reports. And I'm going to draw from each of these in these remarks. The first report was called Global Warming of 1.5 degrees, and I think now you know where that 1.5 comes from. The IPCC was asked to study if it's possible to reach 1.5 degrees and how that could be achieved, and what's the difference between 1.5 degrees versus 2 degrees versus higher levels of climate change. The second report was on the effects of climate change on the land, and the third report was on the effects of climate change on the ocean and the cryosphere. That's the frozen water on the Earth. And I just want to give you the absolute top-level highlights of these reports because they're really important for this topic of the risks of climate change and how we might adapt to them. So this is Botswana, not 1.5 degrees yet, but this is the special report on 1.5. Basically has a couple of big takeaways messages. The first is that the global mean temperature is now approximately 1 degree above pre-industrial levels. So if you look around and see the horrible effects of climate change already happening in the world, like the wildfires on the West Coast, the really aggressive hurricane season that we're in, the wildfires that were in Australia last our winter, their summer, that's what a 1 degree world looks like. They say that business as usual, meaning no really substantial new efforts to reduce greenhouse gas emissions, will lead us to a 1.5 degree world between 2030 and 2052. One thing to know about IPCC reports, because of the way the process works, they tend to be conservative because they really are trying to reflect the best possible consensus. So when you see a range like this, you should generally assume it's going to be on the sooner side rather than the later side. So we're likely to get to 1.5 degrees very, very soon. And finally, they conclude it is physically possible, or as they put it, it's consistent with the laws of physics and chemistry to stay below 1.5 degrees. It's not a very optimistic prediction, but they do say it's physically possible. So that's sort of the upshot of the 1.5 report. To talk about the land report, I need to introduce you to a bit of IPCC insider baseball, but I hope that you'll take this away from this talk, and because you may see this in other places, and it's a really interesting, something very interesting, I think. What you're seeing on the screen is what's called a burning embers diagram. And the burning embers diagram refers to a way of representing the risks of climate change and uncertainties associated with those risks. So it's not giving me easy access to a tool to annotate, but if we look at the first one of these bar graphs, the one that says dryland water scarcity, what we see on the y-axis are a series of temperatures. So there's 1 degree, 1.5 degrees, 2 degrees, 3 degrees, 4 degrees, 5 degrees. That's the increase in global mean temperature relative to pre-industrial levels. And then the color, ranging from white to this kind of, I guess it's a sort of mauve, dark purple kind of a color. The darker the color, the greater the risk of that particular climate hazard occurring. So you can see already the difference between a 1 degree world and, say, a 4 degree world in terms of the risk here of dryland water scarcity. Then to the right of the bar, you see sometimes letters M or H. That refers to the confidence level, and these are precisely defined by the IPCC in terms of probabilities. So as you get further from the current temperature, which is about 1 degree, of course, the confidence goes down. And then below that, below where it says dryland water scarcity, you'll see the systems at risk. So you'll see food, livelihoods, value of land, health, human health, ecosystem health, infrastructure. And a dot refers to a significant risk of that impact. The overall picture is not very nice. I think what you see is that a 1.5 degree world, which is the official target of the Paris Agreement, is a world of many, many hazards, but it's not a kind of zombie apocalypse, completely terrifying world. But it is a world in which we will expect to see, water scarcity, some erosion, some vegetation loss, quite a lot of wildfires, the beginning of the degradation of our permafrost, a tropical crop yield decline, and the beginning of serious food supply instabilities. That's at 1.5 degrees. Already, if you get to 2 degrees, the situation's significantly worse. If you get between 3 and 4 degrees, which is, roughly speaking, the trajectory we're on close to 4 degrees, things look really, really bleak. And pretty much every category you see, extremely high, what they call very high risk of severe impacts or risks in each of these domains. So, we really will face, if we keep with business as usual, huge amounts of drought, huge loss of wildlife and vegetation, huge decline of our tropical crops, and hence massive food supply instabilities. And this is all, of course, against the backdrop of a world where there's an increasing number of people, and so the demands on water and on food and on land are going to be higher. So I'll leave this on the screen for just another moment, but if you are interested in any of this, of course, you can look in the IPCC reports. The most accessible among them is this 1.5 report, and I'll drop a link into the chat a little bit later, or maybe Emily can help us with that. Okay, so then the third of those reports was the report about the ocean and the cryosphere. And basically, the reason that the IPCC wrote a whole special report about this is because 80% of the Earth's surface is ocean or ice, and the global mean temperature increase has a severe effect on both the ice and also on water. One of the things that's happened with climate change over most of the last century is it's been moderated actually by the ocean. So a lot of excess heat's been stored in the ocean, but that's starting to come back and really hurt us, in particular because causing ice to melt. And as ice melts, the sea level rises. And as the sea level rise, we know a lot of other systems are at risk. So here's another one of these burning embers diagrams. You can see that let's just look at across 2 degrees, we have, essentially the destruction of our coral reefs. Our kelp forests are in bad shape. Some of the other things aren't quite as catastrophic. But again, at 4 degrees, the direction that we're going, we pretty much lose all of the categories on this diagram. We also know that sea level rise, which is the thing that's the effect that's most often talked about in connection with climate change. I mean, one of the effects of that's simply going to be that we will lose parts of coastal cities and certain low-lying islands, the so-called small island developing states or SIDS. This is countries like Tuvalu, Kiribati, the Maldives. Some of these countries will just have islands that go completely underwater. But the other thing that happens with sea level rise is they enhance the effect of already existing problems. So, for example, the hurricane season will be much worse in a world with greatly increased temperature because, first of all, there's more warm water for the storm to gather more energy, but also because the sea level is sitting higher than it is now. So if you remember Hurricane Sandy in New York City, which was really quite devastating to lower Manhattan, imagine if the sea was sitting a meter higher and then Hurricane Sandy came in. So you're talking about a big storm surge on top of an already sea that's already higher. So that's the kind of multiplier effect that climate change can have. All right, so this is just a taste of how this Working Group 2 world, the world that thinks about adaptation and risks, starts to analyze the risks of climate change. I have a few more minutes, and I want to talk, before we turn to your questions, and I want to just talk about a couple more issues. And one is, I think we have to talk about extreme weather, because extreme weather is happening now. This was the cover of the LA Times about a week and a half ago, and they, finally, we're starting to see journalists call a spade. They called this California's climate apocalypse. They're starting to really begin to attribute these extreme weather events to climate change. Now, the journalists and frankly scientists too, for a long time, were very reluctant to attribute particular events to climate change, particular storms, particular wildfires. And the reason is because, first of all, that was actually something that the models they're not really great at getting down to the level of individual events that are being pinpointed. But the other reason, and I think this is really important when we talk to people who are either climate skeptics or climate cynics, is because events like these wildfires are what philosophers would call multi-causal events. So here's just like a very basic diagram. If we want to know what causes a wildfire, it turns out to be quite, you couldn't give a really simple explanation. Like my 8-year-old can say fire requires heat, fuel, and oxygen. But one of the things you often hear climate skeptics or those that want to downplay climate say is, well, it's not really climate change that's causing the California wildfires. It was bad forest management. And and bad forest management meant that the fuel load, meaning all the dry materials, just built up over time. Now, one of the reasons that that's a kind of, I think, sneaky and almost powerful skeptical argument is it's not exactly wrong. It's just a myopic view of the picture. I think if we want to know what's the whole story about extreme weather, or in particular with fires, you could say something like this. The extreme fires are being caused by excess heat, and we've been recording the highest temperatures ever this summer, and also by a very, very high and dry fuel load. But then what causes the fuel load? Well, it's a couple of things. One is drought. California has been in an extended period of drought. There's been very high temperatures. And yes, there has been a historical fire management regime of not doing controlled burns and also immediately putting out fires, which does allow fuel to build up. But then, of course, what's causing the heat and what's causing the drought and the high temperature that's building up the fuel load? Well, that really is the result of the increasing global mean temperature. And as I said, again, this is what we're seeing when the world is 1 degree above the pre-industrial levels. The goal of the Paris Agreement is to keep it to 1.5. When we start to get to 2 to 3 to 4, things become really catastrophic. And you shouldn't think of these things as linear. It's not like 1.5 degrees is going to be 50% worse than 1 degree was. It doesn't work like that. How exactly it works is an extremely complex issue and certainly a subject of active research. Okay, so that's the kind of like the risks part. Well, is it possible then to try to achieve 1.5, which I wouldn't call it safe, but would minimize the risk? Well, here's what it will take specifically to achieve it. It will require 45% reduction relative to 2010 of our CO2 by 2030. So we have 10 years to get essentially 50% reduction in our emissions. And then it will require 100% reduction, or I say in parentheses net zero, because it could involve some technologies that remove carbon dioxide, as well as ones that just reduce emissions by 2050. So in 30 years from now, we'll have to get to net zero. And just to give you an idea of how hard that is, COVID-19 and all of the kind of suspension of travel and people staying at home, that resulted in no more than 10% drop over the last 6 months. So we would need, COVID-19 like disruptions every year for the next 10 years to really get there. China, by the way, just announced today that they were going to that their goal now is to achieve net zero by 2060, which is, of course, massively more ambitious than they've been in the past, but that's not sufficient to achieve 1.5 either. So how close are we? Well, it's a somewhat complex diagram, but I think it's important to take a look at that. This came out late last fall, right before the last round of climate negotiations from UNEP. And what this tries to show you is how far are we from the amount of reduction necessary to get to 1.5. And what it's showing us is that even if you take into account the pledges that countries have made in the Paris Agreement, that's what's labeled unconditional NDC scenario, then we're 32 gigaton equivalents of carbon dioxide off. So that level, the actual pledges in the Paris Agreement would take the world to about 3 degrees, 3.1 degrees increase in global temperature above pre-industrial levels. That's not business as usual. That's what was agreed to in the Paris Agreement. Now, the goal of the Paris Agreement was to then increase that ambition as time goes forward, as I said, that China just announced. But there's a long, long way to go, even if the US remains in the Paris Agreement and even if countries meet their targets, which many of them don't seem to be doing. Okay, so that's depressing, but then the question I'm sure some of you have is it still possible? And I think the answer is yes, it is still possible, or it's at least possible to get close. And if you want to know how, there's 2 things that I suggest you look at. One would be this 1.5 report. Chapter 2, which I'm showing on the left side of the screen, is called Mitigation Pathways Compatible with 1.5 degrees C in the Context of Sustainable Development. This is an analysis of, at the very high level, at a kind of nationwide policy level, what kinds of pathways are consistent with 1.5 degrees. So if you are yourself involved in government, or if you have the ear of someone involved in government, this is the place to look for serious, evidence-based solutions about what national policies or city policies ought to be. If you aren't that sort of a person, if you're wondering more like what can you do personally and what can you advocate for more locally, then I recommend you look at something called Project Drawdown. What Project Drawdown is it's an analysis of the sources of carbon dioxide and the kinds of personal policies and regional policies that can be taken to actually really make major effects in climate change. And just drilling into the Project Drawdown for a second, one thing that's really interesting and I think surprises a lot of people, most people think of climate as entirely about electricity production. And, because the talk is often moving away from fossil fuel-based electricity. And that is, of course, something that's absolutely essential. We need to move to renewable energy. But electricity is only 25% of carbon emissions. Another 25% or so comes from food, and the rest comes from a blend of industry, transportation, buildings, and kind of a grab bag of the rest. So when you're looking for climate policies, especially ones that you might have more of a direct effect on, you want to kind of blend your strategies. So of course, everybody, I don't know if anybody who lives in Philadelphia has access to 100% wind and solar electricity that you can purchase. So that's a kind of easy thing that you can do. But it's also worth thinking about other sectors. So it turns out this is a kind of a schematic analysis of different kinds of approaches. But one of the things that you can do is address a lot of carbon emission on the agricultural and food side. So a huge contributor to excess carbon dioxide in the atmosphere is food waste. So a very substantial effort to reduce food waste makes a massive difference. Another food-related thing is moving towards a primarily plant-based diet. Again, agricultural, there's so many things that the industry of producing food via meat There's so many ways that that produces carbon dioxide and removes sinks of carbon dioxide. So we're removing agricultural lands, we're removing forests that could be taking carbon dioxide out. We're growing plants in order to feed animals, and the animals themselves are producing lots of methane emissions. There's a lot that can be done on the food side. Similarly, on buildings, it turns out concrete is a major source of carbon emissions. So that's the kind of thing that can be, people can make a commitment to. And then even really tiny things like changing light bulbs to LED lights. I mean, this is, it seems like small potatoes, but LEDs use 10% of the electricity that incandescents do, and 50% of the electricity that compact fluorescents do. So as even in one house, you can make a difference. But if you're responsible for a building, let's say, or a campus, you can make quite a large difference there. But I really recommend that everybody takes a look at Project Drawdown. But of course, this isn't quite enough. We need to go a lot deeper. And one of the things I invite all of you to do, and we can have this discussion in the chat, and if any of you are really intrigued by this, maybe the alumni office can actually create a follow-up event. There are processes in the UN to try to think about what else is needed and be really, really creative. Really political will is needed, but I think we also need to be thinking about what I'm calling here conceptual infrastructure. What are the most important actions that could be taken? Think about it upstream from the effects of climate changes. What are the most profound things that we could be trying to do as individuals to change society's orientation so that this our relationship with nature becomes a much higher priority than it is now? Do we need to work on social norm changes? Do we need to have different kinds of transactions that reflect our effects on the environment as part of our doing business? I don't know what these things are. It's something that's an active subject of research at Penn. It's something that I work on in my teaching with students, and hopefully we can all work on together. So with that, I show you a little bit of the ice that remains from Penn alumni travel in Antarctica, and I really look forward to all of your questions. Thanks everybody very much, and I will turn it back over to Emily.
Great. Thank you so much, Michael. That was wonderful. Just a reminder, if you have questions that you haven't submitted yet through the Q&A icon, I encourage you to do that now. We've had quite a few questions coming through, so we'll try to get to all of them, but just a note, we only have till 1 today, so let's go ahead and dive in. We did have quite a few questions, pre-submitted questions from Lynn and from, William about what they can do personally to help with climate change. And I think you've addressed that, but if you haven't and people have additional questions, I encourage you to do follow-up in the Q&A. But let's turn to COVID and how that is affecting what is happening. You did touch on how it's helping in a lot of ways with people not moving around as much. But we had another question from Frederick, which touched on what you're talking about with food production. He says that New York City has curtailed its compost collection program until July 2021 because of COVID. If New York City and other programs around the country cease doing this because of financial reasons or other similar programs and material goes directly to landfills, what negative effects will COVID and recession have on climate change?
Yeah, I can't speak so much to compost itself, but I mean, there clearly has been a huge amount of food waste because of COVID. I guess I learned about this just from the newspaper like everybody else, but there's lots of crops that have gone unpicked and everything. And in general, the idea of reducing food waste is to reduce the amount of food production, because we overproduce food, especially in the United States, massively. And then it takes, the goal is to return as much land as possible to trees on the one hand, because that's a net sink for carbon dioxide, and then also to try to move away from using animals that are producing a lot of methane. So I think any time you see food being wasted, that's just that means that it's more of an opportunity cost. So cities could do a lot about this. I mean, in many cities there were problems with restaurants giving their food to food banks, the food that wasn't used. So I think lots of policy changes like that can actually lock in some positive things on the food side. I think I got that. The other thing you asked about effects of COVID, another effect of COVID on international climate policy is that what would have been a very important meeting of the UNFCCC, so COP26, the 26th Conference of the Parties, which was supposed to take place this November in Scotland, has been postponed for a year. Now that is it? I mean, it's just postponed, but the reason it's an important effect is it was the year that this is the year that countries are supposed to submit their updated what are called the NDCs, the nationally determined contributions. This is the level of ambition that the country has for emissions reduction according to the Paris Agreement. So there's definitely, and of course, in general, I think the world's attention has been focused on other things reasonably enough, like COVID-19 instead of like climate. The opportunity, of course, is that you could do not just any old recovery, but a truly green recovery. So one of the things that Obama has been criticized for in the stimulus package back from the late 2000s was that they, for very good reasons, prioritized what they called shovel-ready projects, things that were already planned and ready to go. But it meant that lots of non-green infrastructure got locked in. New highways were built, new bridges were built. We didn't see lots of new electric buses, and we didn't. So that's the kind of thing that we could be pushing for right now politically.
Great,
I'll stop there for more questions.
Sure. I also want to note before I forget that we will send the link to that IPCC information in our follow-up email to everyone so that they can take a look at that themselves if they'd like to.
Yep. Mm-hmm.
That would be great. And then we had a couple questions from a few guests who were talking about how they had heard different things in the news about climate change. For example, Joy said that she read that the global average has actually reached 1.2, and Duncan noted that that there might be different evidence on increasing hurricane strength as a result of climate change. Has the consensus moved on? What would you say to them, and where would you find the most accurate, best information for climate change?
Yeah. So, well, there are two kind of different questions. So on the what's the global mean temperature? It's really hard in any in a given year. It's hard to answer that question because you need to be averaging over some window, and the reason you do that is because one of the reasons it's really hard to think about global mean temperature is there's natural temperature fluctuations from all kinds of things. So you need to have a large enough window that you can actually make a kind of reasonable guess at what the mean is. Usually you see things like ranges 0.8 to 1.2 and 1 is centered in it. I think, the IPCC, these reports come out in cycles. So we're in the 6th assessment cycle. We're working right now on reports that will come out in the next 2 years. I think you probably would get more direct, if you want just measurements, NASA, NOAA, the Scripps Institute of Oceanography, these are kinds of places that you can find more kind of up-to-date things and they'll update them more quickly based on published papers. It depends on your interest in digging down into the published literature, but there's Nature Climate Change is a journal, Climatic Change. But I think NASA, NOAA, Berkeley Earth, these are really good places to look. The Met Office in the UK, you can usually find the most up-to-date information. In terms of hurricanes and fires, so this literature is called event attribution, and I think everything I said is true, and I think that by far the consensus is on this side. What you might be hearing is both a residual of the fact that people were hesitant to attribute extreme weather events to climate change, but also the kind of thing I was talking about. These are complex, multi-causal processes, and even if you can say for sure that climate change is increasing the frequency and intensity of hurricanes, it's hard to pick one hurricane and say this hurricane would not have happened if it wasn't for climate change. It's not even clear that that's true. But really, the problem is that what the theory talks about is frequency and intensity as opposed to individual events. But there's been a lot of technical work on that, and if anybody's interested in the follow-up, I could give some references.
Great, thank you. We have a question from Preeti, and I apologize if I'm mispronouncing your name. She asks, what are the best ways to influence norm change among individuals? Is this best impacted from the top down? How must corporations and government be involved in influencing norm change?
It's such a great question, and someone that hopefully Penn alumni education and travel will invite is my colleague Christina Bicchieri. She is the world's expert on this subject. So if you really, really want a proper answer to this question, I highly recommend her book, Norms in the Wild. She's really fabulous. But I think there was also in the I'm forgetting the name of the publication. It's maybe the Wharton Business Review or something like that. There was an article about her work. I think the answer is that norm change usually comes from a very influential person, and it's maybe not necessarily an expert. So one of the cases that they studied was changes in sanitation practices in India. And it turned out it was a Bollywood star who got interested in this cause of kind of essentially increasing the number of toilets that are available. And that actually led to a huge change. So I don't think it's always so obvious who's going to be the one. I think in climate, we see that the youth have really started to raise consciousness in a way that the political process hasn't. But I think it's a fascinating question. And if you're behind the scenes and you're trying to affect this change, I think you got to just try everything and see, who try to get everybody talking about this, and then hopefully some of it will stick. But it is a really deep and good question. I wish I knew the answer.
And thinking about change, I really like this question. I'm not sure you can answer it, but this is from Steve, if you personally had $1 million, or let's say $1 billion to spend on climate change, where would you spend that money? Or is that a the answer?
Well, I personally think that the biggest bang for if we're talking about something, if I was going to spend money on something, I think $1 billion is not enough to spend at like government level infrastructure projects, right? I would probably spend $1 billion on the food side. I think that's the easiest thing to actually change. I think if we could get people figure out a good way to spend $1 billion to do like what Impossible and Burger has done and Beyond Meat has done, just increase the amount of plant-based eating. I think that would be a huge thing. I'd also probably spend a big chunk of it on the election, because I think the election in the US will play a big role in the future of climate policy. That goes without saying, I suspect. When people ask me, like, what should I do personally about climate change? I always say the number one thing is vote. And if you care about climate, you should vote for candidates who prioritize this, because that's really how policy things are going to change. And then personally, I think you should work on food waste, work on diet, work on personal energy consumption. I mean, things like everything from where you get your electricity from and light bulbs and things like that. Some things that we think are really, really, really carbon intensive aren't always, or savings that we think. That's why Project Drawdown is really good, because it tries to give a kind of realistic look at these issues.
I have another question from Ed, which I think speaks to a lot of the work that you do, especially in the Galapagos with science education. He asks, is there any effort by the community to influence our highly charged politics and misinformation? It seems like that's a significant losing battle, which is critical.
Yeah, it's such a good question. So it's very sad that climate change has become a politically polarized issue. I mean, I can sort of see questions about like, how aggressive should our policies be? How much should they be contingent on other countries being? How much should we focus on mitigation versus adaptation? I get that those might be political. You might have different views. You might wonder about the role of government versus private industry. But evolution is another one. But that climate change happens. It just seems to me so strange and so sad that this has become politically polarized. So I do have some suggestions on this, something that I've worked on. We've done a lot of empirical work on people's, when people resist climate change, when people resist evolution, when people resist vaccines. And here's what we basically find, that acceptance of climate change at the top level becomes politically polarized. So in the US, if you're conservative, you tend to be anti-climate change, the science of climate change. And if you're liberal, you tend to be kind of pro-climate change. But it's more complex than that. So if you dig a little below the surface and you look at people who know more about how science works, people have a greater understanding of scientific methods, then the people that have a greater understanding of how science works, even if they're conservative, tend to be kind of on board with climate change. And there's no variance, or not too much variance on the liberal side. So one of the things that suggests is we shouldn't just entirely focus on getting the message out about this is what climate change is, this is how it works, it's real, but really actually put some real effort as science communicators into the process of science and why we know what we know. And I think that's a very, very important theme for science education.
Yeah, certainly a big challenge.
I can talk about Galapagos all day if you want to talk about Galapagos, but I think that's the key in climate.
Sure, thank you. We had some questions come through about the economics of this. Lyle asks, can you comment on economic policy and how different policies affect support for solving climate problems? thinking that a lot of rejection of climate change science goes directly to the perception that making changes will have great negative economic impact, something that an anonymous person also asked. So if you could talk about that.
Yeah, that's really good. I mean, some of so this is it's not an issue that I work on a lot, but I mean, one of the things is that there's economic questions about mitigation and about adaptation. So on mitigation, I mean, one of the like really big elephants in the room in the U.S. is there's a lot of subsidy to the fossil fuel industry, and so it's thought that if that subsidy didn't exist anymore, then renewables are extremely competitive. I mean, the price of renewables has been dropping very rapidly. So I think removing those kinds of I guess anti-incentives for climate mitigation and or possibly redirecting them, as I think we were starting to see in the Obama administration, grants and other kinds of support for the development of cheaper clean energy generation, super important. So that's one kind of financial thing. In terms of things like carbon markets, I certainly think that's a great idea. It's a carbon tax, carbon markets. This is a harder political lift, but I think in general, the little I know about economics is when there are negative externalities and you can actually price them, it actually changes behavior in a good way. On the adaptation side, I think this is I'm sure that there's a good Benjamin Franklin quote, better than a penny saved is a penny earned. But basically, what's absolutely clear is that even relatively modest investment in building climate resilience today will have massively positive financial implications in the future. So in the new IPCC report that we're working on now, there's lots of discussion about this, like multipliers of 5 times, 10 times, 100 times, depending on the domain, just because there are expected to be absolutely catastrophic losses due to climate change. Quite recently, there was an article on NBC, I think it was this week or last week, again, we could put it in the follow-up email, that discussed actually the military's concerns about this. The military's had more economic losses due to climate change already than they've had from enemy combatants in the last decade or so. So there was recently a hurricane destroyed the hangars that one of the most expensive airplanes were in, and luckily the airplanes didn't get damaged. But there, the Norfolk, Virginia, which has one of the largest Navy bases, the sea level rise there is causing a lot of problems. So I think that's the kind of thing in the adaptation world we think a lot about. This is where early investment will make a huge difference in thinking about climate change.
Sure, thank you. A couple of quick questions. Some people would like to know specifically what the introduction of electric cars and solar energy would have on climate change.
Yeah, so I mean, electric cars are great if your electricity is coming from a clean source. If you have an electric car, but then it's a coal plant that's powering it. I guess it's a little bit better, but it's so you want to couple those things together. So buy your clean energy plan. Yeah, I mean, it's just the less fossil fuel we burn, the better. We want to keep it in the ground, and we want to try to pull it out of the atmosphere. The other thing with solar energy, I'll just say Penn, announced in the spring that we are basically building 2 huge solar plants in central Pennsylvania to produce 75% of the electricity for the campus and the medical center. So those kinds of, Penn is relative, it's not as big as a country, but it's as big as very small countries, I guess, and kind of, it's a huge economic engine. So one of the things you can start to see is that when private entities and subnational actors like cities start to do these kinds of things, making commitments, that makes a big difference. So I would be remiss in not saying, because this is a big Perry Worldhouse theme, the cities produce 70% of the greenhouse gas emissions. And so a lot of times the leaders of cities, the mayors of those cities, are more progressive and more green than the national leadership in their countries. I mean, a good example in the United States right now would be the mayor of LA, the mayor of Philadelphia, the mayor of New York City. So they've made really important citywide commitments to reducing carbon emissions. And there's a group called C40, which is a council of mayors that basically has essentially said, we're going to make these aggressive commitments kind of quote unquote under the Paris Agreement, whatever their fraction is, even if the countries that they're in are dragging their feet. So I think these are all really positive developments, something that even if, we have a change in administration in the US re-enters the Paris Agreement, I hope all of this continues because I think that's really been positive. One
Great,
of our
thanks.
Perry World fellows, maybe you guys will see an event from him this year, is Mauricio Rodas, the former mayor of Quito. So he's a real leader in this movement.
Excellent. Yes, I should let everyone know to check out the Perry World House website. There's lots of great programming happening there as well. Let's quickly move over to climate migration before we have to wrap up before 1 o'clock. Rita asks, how can we plan for migration because of climate change away from coastal flood areas, potential drought and fire zones, hot south, cooler north? What would that look like?
Yeah, I mean it's a huge, it's a really complicated question, and there's also there's going to be climate there'll be climate displacement all around the world. But just talking about the U.S., I mean, you're absolutely right that we need to be thinking about this, and so there are all kinds of this has to be thought about at every level. So at the kind of like simplest level, municipalities should be thinking about how they zone things, and insurance companies are starting to take this really seriously. This is something that happens at the Wharton Risk Center. That's one of their expertise there. But then, yeah, I mean, we need to begin as a kind of world to accept the fact that even under the best case scenario, the kind of 1.5 to 2 degree scenario, a lot of places that are currently habitable are going to not be habitable, and we're going to need to move. So like Duluth is going to be sort of mid-Atlantic temperatures by the end of the 21st century. And so I think, we need to be conceptually ready for that. And then one thing that gets thought about a lot is, what are the ethics of this? So is it, should we get it's right now the poor people that have to move. Should the rich people have to move? Or should we pay for people to move? Should we be, saying we're no longer going to allow insurance in certain areas? And then there's just trying to predict what's going to happen. I mean, there'll be massive, massive demographic shifts in the United States and globally. So one thing I personally worry about is we've seen how around the world leaders have managed to whip up xenophobia whenever there are migrants. So you see it in Europe with migrants coming from Syria. You've seen it in the last few years with Central Americans coming to the United States. We're talking about hundreds of millions of people that will be on the move because of climate change. And are we going to, as a world, be able to deal with that in a humane way? I worry a lot about this.
Yeah, sure. Big questions, a lot to discuss, and hopefully we'll continue this conversation throughout the year and into the future. I'd like to end on if not a positive, at least an action-oriented.
Talking about climate change, man, it's not. It's hard to be positive.
I know. So maybe not positive, but action-oriented. We had a pre-submitted question from Johnson who asked, is there a possibility of collaborating with you in area of training and research in climate change? So maybe not with you personally, but where would you recommend this person goes, or how can they follow your work, Ken's work in the area? And we'll certainly follow up in our follow-up email with this information.
Yeah, I mean, so a couple of things. If you're interested in the built environment, I really think the McHarg Center at the Design School it's one of the premier places thinking about what green recovery could look like, what the Green New Deal could look like, things like that. So that's, if you're interested in the kind of urban issues I talked about, the Institute for Urban Research, which is, I guess it's also in the Design School, kind of a premier place. If you're interested in energy policy itself, the Kleinman Center is this is their specialization. They've been involved in thinking about, for example, the refinery that exploded in Philadelphia, like what should be done with that space. If you're interested in the things that I talked more about, the risks of climate change and also the negotiations, that's a kind of Perry Worldhouse thing. And we just had this morning here Patricia Espinoza, the executive secretary of the UNFCCC. So you could watch that recording, and we'd love your feedback about that. If you're interested in working with local communities on adaptation efforts, that's the kind of work we do in Galapagos, and we're trying to expand that elsewhere in the world. So I'd be very happy to if there's a group of alumni that wanted to have a video chat together to share ideas and to think, how we could take this to different regions, that would be great. So I think this is really, climate change is not a problem that a few elite people can solve. This will be the issue that defines the next 50 years. And so I think if those of you still watching and beyond eating less meat and having LED light bulbs and voting, I think there's lots and lots and lots of things to do and talk about and discuss. I'm very happy to continue that discussion.
Great, thank you. So this is certainly a starting point, a jumping off point, and we will continue the conversation And I will pick Michael's brain at the end of this talk to make sure we get all of this in the follow-up email. So I want to thank Michael so much for joining us today, and to all of our attendees and our participants. I hope you enjoyed the session as much as I did. If you'd like to review any parts of today's webinar or share it with a friend, the recording of this program will be available on our website within 1 week, usually within 24 hours. And I hope you'll join us for our next Global Discovery webinar. It's with Professor Herman Beavers on October 14th. A very different topic, but also a very good one. It's called The Bluest Eye at 50, Reading Toni Morrison in the Age of Trump. So to register for this program or any of our Global Discovery Series webinars, all on very important topics, visit alumni.upenn.edu/Global Discovery Series. And it sounds like so many of you are so interested in climate change. I encourage you to check out Climate Week at Penn. All this week, there's virtual programming happening. Just Google Climate Week at Penn and you will find it. And lastly, please take a moment to complete the short survey that launches at the end of this session. Your feedback helps shape our future programming. So again, thank you for joining us, and we'll see you next time.